Lesson 10. Trig Ratios for 0 degrees and 90 degrees. In the last lesson, you learned that standard position for angles provides a way to define trig ratios for values of theta that arise outside of the context of right triangles. Two such values are 0 and 90 degrees, that is, 0 and pi/2 radians. To see how this works, we'll begin with a unit circle. Note that we can embed any right triangle with a hypotenuse of 1 onto this circle, with the angle theta in standard position. As theta gets closer to 0, the length of the opposite side of the triangle also gets closer to 0, and the length of the adjacent side gets closer to 1. From here, it is only a small abstraction to consider what a hypothetical triangle with an angle theta equal to 0 might look like. If such a thing were possible, its opposite side would have a length of 0, and its adjacent side would have a length of 1. Its hypotenuse, of course, would have a length of 1. This abstraction provides a useful way to calculate the trig ratios when theta equals 0. For example, the sine of 0 degrees equals opposite over hypotenuse, which is 0 over 1, so the sine of 0 degrees equals 0. The cosine of 0 degrees equals adjacent over hypotenuse, which is 1 over 1, so this value equals 1. And the tangent of 0 degrees equals opposite over adjacent, or 0 over 1, which equals 0. In a similar way, we can create a meaningful abstraction for theta equals 90 degrees by imagining what happens to an embedded right triangle as theta approaches 90 degrees. In this case, the opposite side increases towards 1, while the adjacent side decreases to 0. So a hypothetical triangle with an angle theta equal to 90 degrees would have an opposite side of length 1 and an adjacent side of length 0, while the length of its hypotenuse would remain 1. This abstraction allows us to calculate the trig ratios when theta equals 90 degrees. For example, the sine of 90 degrees equals opposite over hypotenuse, or 1 over 1, which equals 1. The cosine of 90 degrees equals adjacent over hypotenuse, which is 0 over 1, so this value equals 0. And the tangent of 90 degrees equals opposite over adjacent, or 1 over 0. Note that this value is undefined, so the tangent of 90 degrees has no numerical value.